Good morning, this is your Stat Sensei, Mr. Spensei, and this is Death Packet Questions for Proportions, Problems 81 through 90. A researcher has conducted a survey using a simple random sample of 50 registered voters to create a confidence interval to estimate the proportion of registered voters of favoring the election of a certain candidate for mayor. Assume that a sample proportion does not change. Okay, so we got the same. Which of the following best describes the anticipated effect on the width of the confidence interval if the researcher were random sample of 200 rather than 50? So we had an original of 50 and we want to do a new of 200. All right, so here's what I would do. I would go to that formula that I showed in a previous video where I had 1 over the square root of, make that a double bar, new over the original equals effect on the width. So I'm going to use delta width, delta being change, the change in the width. All right. Well, in this case, they gave us the new and they gave us the original. So we have one, we're going to have 1 over the new is going to be 200, the old is going to be 50 equals the change in the width. Well, 200 divided by 50 is 4. So we're going to have 1 over 4, 1 over the square root of 4 equals the change in the width. All right, well, I can take the square root of 4 and I get 2. So I have 1 over 2 equals the change in the width. So the new width will be 1/2 as wide. So we'll have half the width. So the width of the new interval would be 1/4. No. The new interval would be 1/2. Yes. All right. So the best answer choice for 81 is B. All right. Moving on to 82. In general, the how does doubling the sample size change the confidence interval size? We'll go back to that formula we just used. 1 over the new over the original equals the change in W, or the change in the width. So in this case, they didn't give us any numbers, so we'll have to make some up. So let's just say my original was 18. We can choose any number. Well, the new one has to be twice that, so twice 18 is 36. Well, 18 divided by 36 is 2. So I end up 1 over the square root of 2. Well, if I take the square root of 2, 2 raised to the half power, I get 1.414. So 1 divided by 1.414 equals delta W, where delta W is the change in width. So divides the interval by 1.414. So if this is my interval, I'm dividing it by 1.414. All right. So a confidence interval estimate is determined from the summer earnings of a simple random sample of n students, all other things being equal, which of the following will result in a smaller margin of error. Okay, so first one, confidence level. As confidence level goes up, ME goes up. So that won't work. A larger sample standard deviation. Okay. Depends on how you want to look at this, but we'll go ahead and look at it in two different ways. But generally speaking, it's the way to express this as the standard deviation or sample standard deviation goes up. The standard deviation goes up, whether it's a form A, here let's use S, as S goes up, margin of error also goes up. A larger sample size, as N goes up, margin of error goes down. So this looks like that. And those are just garbage answers. Our best answer is 83 is C. 84. The school superintendent wants to know what percentage of property owners are willing to support an increase in school taxes. What size sample should be obtained to determine with 90% confidence level to within a percent 5%. So our ME equals 0.05, our CL equals 0.90. We're going to go back to the formula that we've used several times in the previous videos. Z equals Z star squared P hat times 1 minus P hat over ME squared. So if I'm plugging in, I know my margin of error is 0.05, so 0.05, make sure you square it. I can get Z star by going second vars, inverse norm, 0.90, mean is 0, standard deviation of 1 for all Z's, keep it centered, and we have 1.6448. All right. And then P hat times 1 minus P hat. Well, they didn't give us any P's. They didn't give us P or P hat. I don't have either of them. So with that being the case, I'm going to have to use the worst case, which is 0.5. So 1.6448 squared times 0.5 times 0.5 divided by 0.05 squared. 270.5. So N equals 207.5. And so that means N is 271. So the answer to 84 is C. 85. A researcher has conducted a survey using a simple random sample of 50 voters to create a confidence interval to estimate the proportion of registered voters favoring the election of a certain candidate for mayor. Assume that a sample proportion does not change. Which of the following best describes the anticipated effect on the width of the interval if it changes from uh, changes to 50, 200 rather than being at 50. So we originally had 50, we had, and we're changing it to 200. We actually did this in a same problem in another video, but I'm going to work through it again. So we're going to go back to using the formula that the one that came up with. It says 1 over the square root of the new over the original equals the change in the width. All right. Well, we know that the original, so we already know the original was 50 and the new was 200. So 1 over the square root of 200 divided by 50 equals delta W, the change in the width. Well, when I take the calculator and I go 200 divided by 5, I get, oops, two, 200 divided by 50, I end up getting 4. So I have 1 over the square root of 4 equals delta W. And I can take the square root of 4 and I get 2. So 1/2 equals the change in the width. All right. So the new one will be half as old as the other one, as the original. Width of the new interval will be 1/4. No, got to be careful. The width of the new would be about 1/2. Yeah. So 85 should be B. 86. USA Today reported that speed skater Bonnie Blair had won the USA's heart, according to USA CNN Gallup poll, on the final Thursday of 1994 Winter Olympics. When asked who was the hero of the Olympics, 65% chose respondents chose Blair, who won 5 gold medals. The poll of 615 adults done by telephone had a margin of error of plus or minus 4%. Which of the following statements best describes what is meant by the 4% margin of error? All right. So in this case, 65%. Now remember, we're always talking about the population. So the population would be 0.65 plus or minus 0.04, which means a low of 0.61 to a high of 0.69. All right. So it's likely that the true population of people that were thought that she was the sweetheart is in that interval. All right. So about 4% of the adults were expected to know, did not have to know, no, no. The difference between the sample percentage and the population percentage is likely to be less than 4%. Um, that's a true statement. I don't really like that statement. Um, that's that. Let me rephrase that. That is the best answer. We're just going to go with that. All right. We're saying that it's not likely to be more away than what we have. So it's not being likely being more than 4 points away from 65. And we believe that it could be as low as 61 and as high as 69. All right, 87. Should there be more restriction on handguns? In a 1995 pre-Columbine survey, 255 out of 1,020 adults answered in the affirmative. In the 2000 post-Columbine survey, 352 out of 1,100 answered affirmatively. Establish a 90% confidence interval estimate for the proportions. Okay. So first off, 90%. Let's deal with that. That's probably the easiest part. Second vars, inverse norm, zero point 0.9. And as soon as we do that, we find out, hey, 1.645. Well, we are down to guessing. At that point, we have these two intervals. Well, I'm just going to show you what I would do to speed through this if I was taking a test and I wanted to know if I mean, I know the formula, so we need to know the formula, but let me show you where these values come from. So if I went to a two proportion Z interval and I plugged in 255, 1020, 352, 1100, and then I put in 0.90, there's my 25%, there's my 32%. So that's P1 minus P2. That's where that came from. That said, you still have to know the formula, and you have to know the formula looks like this. All right. So our best answer is A. All right. 88. For two populations of rabbits R and S, the proportion of rabbits with white markings on their fur are given as PR and PS respectively. Um, suppose that the independent random sample of 50 rabbits for R and 100 rabbits for S are selected. What is the standard deviation of the sampling distribution of PR minus PS? Wow. All right. So with this one, now this is going to be an interesting question to me. We need to know our formula and our formula for confidence interval, and it doesn't say confidence interval, so it really should have um, our formula for confidence interval in this case. Um, I need to pause this for a moment while I think about how to explain this. All right, so they should have told us this was for a confidence interval, but regardless, the standard deviation of the sampling distribution is going to be equal to the standard deviation of the population. So we need to be using population. So anything with the word, anything with p hats can go away. So we're now, the p-hats, they're wrong. Well, our formula in this case is P1 times 1 minus P1 over N1 plus P1 or P2 times 1 minus P2 over N2. And the one that most looks like that is this. All right, because the rest of them, these two do not have a square root. So our best choice for 88 is D. All right, 89. In one city, 75% of residents report that they regularly recycle. In a second city, 90% report that they regularly recycle. Simple random sample of 75 residents are selected from each city. Which of the following statements is correct about the approximate normality of the sampling distribution um, of the difference in sample reports who report they regularly recycle? All right, so we're talking about normality, which means we need to go back to how do we show normality? So I'm going to make this city 1, and this is the one with a 0.75. And the city 2, it's 0.90. Well, if I'm checking for normality, I need to go N times P and then N times 1 minus P. That's the way I'm going to do that. And I'll need to do that for both of them. And they said that they had we've sampled 75 from each one. So this is going to be 75 times 0.75. And this is going to be 75 times 0.25. This is going to be 75 times 0.90. And this is going to be 75 times 0.10. All right. So let's check it out. 0.75 times, excuse me, 75 times 0.75 equals 56.25. We're good with that. 75 times 0.25, that's 18.75. We're good with that because we need to be bigger than 10. That should be bigger than 10. Then 75 times 0.9, oop, 75 times 0.9 is 67.5. That's big enough. And then I go 75 times 0.1, and I end up with 7.5. Not big enough. So both samples are large enough? No. The sampling distribution is not approximately normal because although the sample size of the sample size for the second city is not large enough. So for 89, the sample size for the second city is not large enough, even though it is large enough for first one. All right. 90. Researchers in plant growth are investigating the proportion of seedlings that sprout under two environmental settings in a lab experiment. That P hat C represent the sample proportion of seedlings that sprout in garden C, and P hat H those in garden H. Random samples of 100 of garden C and seedlings in 100 garden H. So we have two samples of 100. So basically, when we subtracted those two, when we ran the hypothesis test, we ended up with a um, standard deviation of the two of being 0.0051. All right. So on 90. All right. So there's a whole lot of this to read. And as opposed to me reading it all, I'm going to let you read it. I'm going to focus on the answer. So which of the following is the best interpretation of the standard deviation? Is approximately 0.051. Well, remember, we're taking a difference. All right. And the standard deviation is really the average of the differences. So for all random samples, and the reason I say for all is because we're talking about the population, because we're making estimates about the population. For all random samples of 100 seedlings and 100 garden age seedlings, the average distance of differences between the sample proportion from the mean is approximately 0.051. All right, because standard deviation is the average distance you are from the mean. This and then it has to be all possible differences. All right, all possible differences. We look for that because we're talking about the sampling distribution. All right, so the sampling distribution is all possible differences. The problem with this one, which is really close, is this is talking about the mean of the differences. And here we need to be talking about how far you are from the differences, the distance, the average distance of all possible differences. All right, because that's standard deviation. Standard deviation is the average distance. And this was what makes this answer about standard deviation. All righty. I appreciate you watching. Hope to see you on the next one, and I hope this helped. Thank you.